Welcome to Geometry Comp Features. The geometry component is an essential part of a render network, so let's take a closer look at the features of a geometry component and how we can take advantage of them. Let's set up a basic render network by using the Tab key to open up our Upgrade dialog. Here in the component family, let's hold down the Control key and add a camera and a light. Let's head over to the top family and add a render top here into our network. Now, I'd like to add something that isn't a torus, so let's begin by opening up the Upgrade dialog. Again, let's add a sphere SOP here to our network. Right-click on the output to the sphere, and then head over to Component and add a geometry component. So this is set up for us. Now, I'd like to actually just animate this left and right, and we could do this a few different ways, but let's begin by looking at how we can do this with chops. Let's open up the Upgrade dialog, head over to the chop family, and find an LFO. Let's add our LFO into our network, and we're going to connect this to a null. Now I'm going to use a shortcut to do that. I'm going to hold down Alt-N, and then add a null here to my network. Now I want to use this movement to actually affect how we're moving our sphere here. So I'm going to go ahead and select the GO1. I want this to translate in the X position. So I'm going to make my channel operator viewer active here. I'm going to click and hold down the left mouse button and drag Chan1 right over to the translate parameter and release and select chop reference. Now we can see I've got this moving already. That's great. And I'm going to head back to my LFO and I'm going to turn down my frequency to maybe 0.1. So this moves a little bit slower. Now we have a few options for how we might resize our sphere here. One thing that we might think about doing is scooting over our surface operator to make some more room, right-clicking on our wire, inserting an operator that's a transform, SOP here, and then changing the scale of this down. We could turn this down to maybe like 0.1 to make this a little bit smaller. Now we've got a little sphere that's moving back and forth. Now, this is a perfectly reasonable way for me to think about making changes to the position or the scale of a surface operator if I'm not actually updating that every frame. Anytime I'm animating the update of a parameter for a surface operator, I generally want to try and do that, if possible, at the geometry component level. So let's take a look at what I mean. So let's actually take this expression here. I'm going to highlight it. I'm going to cut it from here. I'm going to head over to my transform SOP, and then I'm going to paste it here and translate. Oops. Let's paste it right here in the translate field. And we can see this has the same effect, but if I middle mouse click on this transform SOP, I see that this has a CPU cook time. So this is actually cooking on my CPU. And this costs me a little bit of the budget that I have for any given frame for how much computation time I have. It's more efficient for me instead to do this operation, this transformation, left and right, or even scaling operations if I'm going to do it every frame on the geometry component itself. So let's go back. Let's go ahead and select that expression. Let's cut it, head back to our geometry component, and then paste it back here in TX. Excellent. Next, let's take a look at how we can use an expression to create some animation. So I'm going to head back to transform. I think I'm going to turn that up, maybe that's 0.25, so it's a little bit larger. And let's go ahead and add a box SOP here to my network. Now with my box SOP added to my network, I'm going to right click on the output. I'm going to select a geometry component again and add this to my network. Excellent. I think I want to spin this slightly, so I'm going to go ahead and just rotate this here. 45 degrees and 45 degrees. Excellent. And then I think what I want to do is I want to continuously rotate it here in this other parameter. I'm going to use the display flag to put this in the background so we have a better view of this. So I want to keep this spinning. I can use a simple Python expression for this. And let's go ahead and open up the parameter so we can better see it. That looks like ABS, lowercase, capital T, time, dot seconds. abstime.seconds is a way for me to grab the absolute amount of time that TouchDesigner has been running as expressed in seconds. Now, this is moving pretty slowly, so let's multiply that by, say, 45. Excellent. So now I have two different types of animation that's happening here inside of my scene. This is great. Now, I want to look at one other way that I might work with some of the features of my geometry components, and that's by using hierarchy. So I'm going to go ahead and scoot over these a little bit here. I'm going to turn off my render flag, or my display flag, excuse me, for just one moment. And I'm going to scoot this over here as well. Now, hierarchy allows us to build relationships between operators that preserves their transformations, but allows us to apply a pre-transformation. So I'm going to start with a null component so we kind of better understand what that means. Now, my null component has all of the features of a piece of spatial geometry, but does not render anything. So this is a great way for me to think about how I can manipulate a point in space without actually having any geometry in it. In some applications, this is referred to as an empty. And this is a great way for us to think about a transformational shape that we want to hold on to that we can apply to other operators. So I'm going to use top-bottom connectors to create some hierarchy here between my null and my Geo1 and Geo2. And the result here is that now I can perform a transformation, say left or right here with my null, and that's going to maintain the spatial relationships that already exist with these other operators. This is really helpful for me whenever I'm setting up a render network and want to think about creating some of those relationships so they're persistent. This is just a few of the features that we can work with on geometry components, and it's just the beginning of the work that we can do.